Thank you, Eric, for the introduction. Good afternoon, everyone. And thank you, QuanTech, for having me here. As mentioned, my name is José Antonio Guerrero-Colon. I'm a senior data scientist at RavenPack. And yes, we have been providing news analytics for finance for almost 10 years now. And I'm here today to talk about how to use big data analytics in trading, some inspirational ideas on how to use our data set, and hope you find it interesting. So this is the outline of the talk. I will start providing a brief introduction about the way we structure the content and the key capabilities we rely on in such a structuring. After that, I will jump into what I call the spine of this structure, which is the RavenPack event taxonomy, where we consider more than 2,000 different event types. And in the next section, I will show how some techniques on how to use the taxonomy actually for trading, and some techniques on noise filtering and for increasing the trading opportunities we may have. And in this section as well, I will provide our latest research results, and finally some conclusion and future work that we are planning to do. So in general, as I mentioned, our goal is to provide big data analytics for finance, and our job is to turn large and structured data sets into the structured content streams that are easier to maintain, manipulate, and analyze, and that are very useful for a wide range of financial applications, both for increasing performance and profit. So let me start talking about the way we structure the content. As I mentioned, we rely on three main capabilities. Our starting point is obviously unstructured content coming from many different sources. Traditional news wires like Dow Jones, Wall Street Journal, Barron's, MarketWatch. Also, we have press releases and more than 19,000 online resources. And this is just text information of the news. The first capability we have in place is the entity recognition. So this one is very important because we have to be able to know what are the news about in order to identify the entities we can trade on based on those news. We have many different entity types, companies, of course, currencies, commodities, organizations, places, everything we extract from this unstructured content. The second key capability is event detection. As I mentioned in the introduction, we do have in place a very elaborated taxonomy expanding more than 2,000 different categories. And this is not only useful to know what event type we are dealing with in the news, but also to identify the role that a particular entity is playing in that particular story. So for instance, let's say we have an acquisition merger event happening in the news. We might be able to tell you which company is the acquirer and which company is the acquiree. Or in a lawsuit, who is the defendant and who is the plaintiff. So actually very useful. And the third capability is the ability to provide a score for every single record. We have many different scores. I just summarized here the three important ones. One of them is relevance, and it's related to how prominent is that particular entity that we detected within the news. The other one is novelty, which refers to how new, how novel is that particular news. And the other one is sentiment. Sentiment will provide the strength and the direction we should expect to see in the market when an event like that happens. All right? So this scoring is very useful both for filtering and also for aggregating into indicators that in the end are useful to trade, because we can consider them as signals. So this is more or less the process, and this is the shape we have in the database. It's just a hand selection. Worth to mention that we do provide real-time delivery, so we have timestamp up to the millisecond. The columns are color-coded to showcase the different capabilities. Just a comment on the RavenPack ID. We do provide point-in-time sensitivity identification of the companies across the whole story. And we do have in green this score that I will get back to them in the use cases. And of course, the columns that implement the taxonomy. So let's take a closer look to the taxonomy here. And this is a tree visualization of our taxonomy. From top to bottom, we can find 5 different topics: business, economy, environment, politics, society. At the next level, we expand more than 50 groups. Events like earnings, analyst ratings, insider trading, layoff, etc. The next level cover more than 400 types. And globally, we do cover more than 2,000 different categories. So having such a structure is very powerful and very useful to provide non-uniform treatment of the sentiment. What do I mean by this? Is that, for instance, we can take into consideration all the events happening for a particular entity or set of entities and combine them using aggregation to provide a global indicator. But we could also go what we call thematic vision of the indicators and focus only on one particular theme, so for instance, earnings. This is also useful because we can model the decay of those particular events, because it's reasonable to assume that, imagine, earnings and analyst rating tend to decay faster as they are very impactful in the market, as compared to other events like maybe acquisition mergers. These two are not only the only dimensions we can use. We can use any other information and have an overlay over this structure. And we can filter by sector, region, market cap, a combination of all of them. And we can have things like, I don't know, indicators for technology companies on Russell 1000, for instance. So we can go very granular. However, we have to bear in mind one thing, that the more granular we go, the less liquid we get in terms of number of news. And this is actually the main challenge that we face when we try to use and exploit this type of data. Because we have to be able to filter out noise, but we still want to increase the number of trading opportunities we do have. And the next slides, I will show you how to use the data sets in order to provide these techniques. So for filtering the noise, we already have in place some simple procedures, and we just focus on the novelty and the relevance that I showed you before. The novelty is just a score between 0 and 100, providing information about how novel is that particular news. So for instance, if we are only interested on breaking news, we will filter for novelty 100, and we will drop everything else. In a similar fashion, we do have relevance, which is also a score between 0 and 100. And in this case, describing how prominent is that particular company in the news. So for instance, if we are only interested on entities that play a key role on that particular story, we will filter by 100 to get that information. This is not the only way we can use the taxonomy to filter for noise, so it's still potential for more further sophistication on the filtering. And one way to go is to filter out event types that are not performing historically. So imagine that we focus on earnings, on the earnings category. We could do things like track the historical performance of every single category. And we can keep those that performing over the past and drop those that didn't. And we can do that in a rolling fashion. And the strength of the indicator will get much better. I will get into more detail because this is actually one of the use cases I want to show you afterwards. Another angle to noise filtering might be to define state diagrams. So let's say this is the state diagram for acquisition and merger event. And with this in place and having the knowledge of what's the current event or the last event we saw about this particular entity, we can have information about what are the most likely events coming afterwards. But even better, we are able to have a pretty good idea of what might be considered to be a delay event or even noise, and just drop them. So it's a very good way of filtering for noise. If we take this idea of tracking the status of a company across the taxonomy, we can actually use it to increase the trading opportunities. If we are able to model or identify event patterns, we can use inference to actually anticipate impactful events. So we can elaborate on things like what's the probability of having a positive analyst rating event, provided that we have 2 positive events on earnings and credit ratings. Another approach to increase trading opportunities is related to how we exploit the relationships between entities. And basically, the idea is to build networks based on some metric and actually propagate the information we have across the network so that we spread the information we do have across those related entities. The key thing is how we do relate the companies. One way to go is to have a look to the conventions in the news. How often are 2 different entities conventioned in the same story? That might have an impact. If we see a news on one, might have a spillover effect on the other. Or we can use the competitive landscape to do the same. If 2 companies are competitors, they might be related, and one news in one company might affect the other. Or in the same fashion, use the supply chain. So who are my customers or who are my suppliers, and try to exploit this information. And now let's stick to the fun stuff. I'm going to present how to build earnings indicator. We are going to take the thematic approach to it, and we're going to use this historical performance to reduce noise. And after that, we are going to spread the information that this indicator provided using the supply chain information to build the network. So as I mentioned, the starting point is event filtering. Event filter, we do have only earnings news, and the first step is to evaluate historically every single category. To that end, we define a look-back window, and we stack together by category all the events and try to track what's the performance over time in a cross-sectional fashion. At this point, we do have in place a number, so we know which categories provided performance and which not. And to decide on the indicator for one particular day, we just stack together all the events for the day, this time by company. We drop out those categories not performing, and we just aggregate using a simple aggregation. So, as you can see, very simple methodology, and the only thing we have to take care about is the look-back window. So how to decide on this particular parameter. So in order to have a look, to have a sense of how this parameter behaves, we use a range of different window size from 1 month to 2 years. We construct an indicator for each one of them, and we test it across 4 different universes: Russell 1000 and Russell 2000 for the US, and the equivalents in the EU. And we also explore the holding period from 1 to 21 days. So in each picture, it's represented the result for each universe. And we can see that the shape is very similar. So we can say that we are not much affected by overfitting. Here in Europe, small cap, we can say that kind of we are benefiting from taking larger loopback windows, but we can explain that by the liquidity in the news that we do have, because compared to the US, it's much less news. So, as I mentioned, it's consistent across the board, and we are not much exposed to overfitting, and for that we decided to take the longer window so that we can benefit those categories that are not that liquid. For the results, we just put in place some long-short daily strategies, indicator weighted with a maximum location constraint of 5%. As a benchmark, we use a standard earnings database. We just use standardized unexpected values, which is just consensus, actual minus consensus divided by the standard deviation of the consensus, and compare it across all the universe. Our results in red, earnings consensus in blue. As we can see, we do outperform in 3 out of 4 universes, providing very good profiles. I would say that in the more scalable universes, which are the large cap ones, we do significantly outperform. Another interesting thing is that we do find a low correlation between the standard database and the information that we are providing. So this definitely opens the door to actually combining the information. The reason behind this low correlation might be in the different coverage that we do provide as compared to the benchmark. We provide broader coverage, and also an explanation might be on the directional discrepancies, that as we are only in the same direction on around 70% of the time. So everything is good so far, but the problem is, of course, this is not meant to be used as a standalone signal, because as a standalone signal is a very high turnover signal. We get a lot of transaction cost. Besides, the portfolios are very small, and hence we suffer from low diversification. And one solution to this might be to extend the trading period. And we did that from 1 to 21 days and track the performance. Here, I'm focusing only on US large cap. And we are testing holding periods from 1 to 21 days. At the top, we can see the performance in terms of information ratio and analyst return. We can see that we still outperform. And we are providing information ratios around 1 even after 21 days. And at the bottom, we can see the features of the portfolios we are providing. We can see that we significantly reduce the turnover, and obviously the portfolio size is increasing linearly. So yes. So this solution was based, as I mentioned, on extending the holding period. However, we could use one of the techniques I presented before, which is spreading the indicator information into a network constructed using the supply chain information. And if we do that, this is very preliminary results actually from just a couple of weeks. And if we do expand from the customers to the suppliers, this information, this is the profile we get. So we can see that we hold some predictive power here. Another thing is that mission accomplished, we do increase the portfolio size significantly. And not only that, we provide, this profile is very, very low correlated. This is less than 1% correlation with the initial indicator. So this really provides a potential source of orthogonal alpha to be combined with the initial indicator. And what time is it? Well, so that's basically it. I have presented you how we do construct big data analytics, how we structure the content based on these 3 capabilities, the entity and event detection plus the scoring. I have described further the event taxonomy, and we have seen that it's very useful also for noise filtering and for signal propagation. And as a result, the use cases provide very promising results. as future work, apart from trying to expand this thematic indicator idea into other themes like insider trading, analyst rating, the most impactful ones, we want to keep exploring the inferential relationships, trying to find patterns across the taxonomy, because we believe that it will have a strong impact on the strategies, as we will be able to position ourselves even before the event is happening. So it's quite challenging, but we are quite optimistic about it. And in other regard, we want to also to work in earnings prediction based on transactional data. And that's it. Thank you.
So we do have time for questions, and we should make use of those questions. In fact, Jose has to fly back. He will not be on the panel, but we have questions now. We have questions over the coffee as well.
Yeah.
On the panel, we will have his colleague.
Yes.
Just as good, Jack Riley, who's based in London. So questions, let's have them now. And we have a roving microphone, yes.
Yes, very interesting presentation. So I was wondering whether you can give a bit more details on how you measure, for instance, like novelty or relevance as features of like the news items.
Yes. Novelty, for instance, is based on is a score between 0 and 100, and it's based on a 24 hours period silence. So we have like an exponential decay within 24 hours. As the events are coming, we just degrade the score. That's in terms of novelty. In terms of the relevance, relevance is related to how prominent the news are. And we have two things here in place. One is if the company plays a key role on the event, for instance, if it's the acquire or acquiring and acquisition merger event, it will have 100. Or if it's mentioned in the headline. As the detection is made farther down in the story, we will degrade based on different algorithms.
Further questions? I have some, but I want to give the audience the first chance. I've actually got two questions.
Okay.
The first question is how stable are the sort of indicators that do you find that they're stable over time? Do they last a long time? Are they persistent? Or do you have to select the signals that you filter on? Is that a dynamic process? Do you see it changing over time? Do some things come and go?
Okay, so you're referring for a particular entity or in general as a trading strategy? I will answer both.
Well, you showed the red and the green, the ones that you kept, that you thought that had information, and the red ones where you said...
Oh, yes.
Yeah.
Oh, yeah. Yes, well, actually that behavior is very smooth. So the profiles, as you have included in the slide, the profiles are quite smooth as suspected. So that means that we have a good taxonomy in place. The thing is, we believe we're trying to better understand that, but we believe it really depends on the regime shift we find in the market, because depending on the market regime, we can have certain events having performing or not performing at all. For instance, in the financial crisis, it doesn't really matter what earnings you get out, that it won't probably matter much.
The performance that we show, would you describe those as out of sample or in sample?
Well, the thing is, and that's the reason behind having this presentation, this slide, which is to be safe out of the overfitting thing. The thing is that the methodology is based on a rolling window. So it only has 2 years memory.
Okay.
So we are not really being affected by this out of sample. Of course we are, but to some extent we are alleviating that by exploring into the universe of different windows that we can have.
Yeah. And I have a final question. Maybe I should have stressed that in the introduction. RavenPack provides help to traders. RavenPack doesn't trade itself. So my question is, how do you work with clients? Do you give them the full taxonomy, let them decide? Do you give them signals that you agree with? How do you kind of transfer your analysis? How do you make it available to clients?
Well, maybe this is a better question for Jack, but I will do my best, Jack, to answer that. I have a slide that actually summarizes, this one. So basically we have two different types of products, what we call the granular data, what is the one I have already shown you, and the other ones are the indicators. We have different versions. And we do provide, in terms of the delivery, in real time, and also daily, monthly, and updates, and 30 minutes updates in case of the indicators. So basically, these two things are more or less the way we try to help. I don't know if that answers your question.
It does. Thank you very much, Jose.
Okay, thank you.